Take a breath and notice the rhythm of your own awareness. Not the shallow rush of daytime thought, but the slower tide that arrives when you let yourself pause. This is the place where the boundary between ordinary reflection and cosmic wonder begins to soften. Imagine the room around you fading into a dim hush. The hum of appliances, the flicker of screens, the chatter of routine, everything settles, leaving you with the steady beat of your own consciousness. In that stillness, a question appears. What if the very act of being aware connects you to the fabric of the universe itself? This is not a casual question. It is the kind of inquiry that philosophers, mystics, and scientists have circled for centuries. And now, quantum physics, the science of the very small, has entered the conversation. It suggests that the mind you're using right now may not be sealed inside your skull, but instead entangled with processes that ripple across the cosmos. Think of consciousness as a lantern. You usually hold it close, lighting only the immediate ground of your personal thoughts. But when that lantern is lifted, when its beam stretches outward, it can reveal patterns in the night sky, patterns linking the spark inside your neurons to the symphony of particles and fields that compose the universe. And yet, how can this be? The brain is warm, wet, buzzing with biochemical noise, the last place you'd expect to find delicate quantum phenomena. Physicists once argued that quantum states could not survive there for more than a fraction of a second. But a new frontier of research whispers otherwise. So tonight, our journey begins with this bold possibility that your awareness is not merely a byproduct of neurons firing, but a participant in the universe's deepest processes. This doesn't mean certainty. Science still debates, still stumbles, still argues fiercely. But within those arguments glimmers the idea that to be conscious is to brush against the fundamental structure of reality. From here, the path unfolds like a quiet river. We'll follow it from the hidden architecture inside your brain cells to the vast fields of quantum information that may connect all things. We'll meet skeptics and dreamers, theories and experiments, each a stepping stone toward understanding what it means to be aware. And as you listen, you may notice your own mind doing something remarkable. It isn't just receiving words, it is weaving them into experience, choosing what resonates, what lingers, what drifts into the background. Already in this simple act of listening, you are participating in the mystery itself. Awareness shaping reality, one moment at a time. Take another breath. The lantern of your attention is lit. Now let us step together into the first chamber of this exploration, where the microscopic highways of your neurons might conceal a secret world of quantum circuits. Picture yourself shrinking inward, descending from the scale of neurons to the level of cellular scaffolding. Here, inside each nerve cell, run hollow filaments, delicate tubes no wider than a strand of spider silk's shadow. These are microtubules, the structural beams that hold neurons in shape and guide molecular traffic. To classical biology, they are the quiet engineers of cellular order. But to some daring scientists, they might be something for far stranger nature's hidden quantum circuits. In the 1990s, an unusual partnership formed. Roger Penrose, a mathematical physicist known for his work on black holes, joined forces with Stuart Hameroff, an anesthesiologist who had spent his career puzzling over the mystery of consciousness. Their collaboration looked improbable: abstract geometry meeting operating room pragmatism, but their shared conviction was that neurons firing in networks could not, by themselves, explain subjective awareness. Together, they proposed the Orchestrated Objective Reduction Model, or OR for short. At the heart of their theory sat the microtubule. Penrose and Hameroff suggested these structures were not merely passive beams, but quantum engine sites where particles could exist in superposition. where states of possibility could overlap, and where the collapse of those states might generate the frames of conscious experience. Instead of billions of neurons alone creating mind, it could be trillions of quantum events flickering inside microtubules, orchestrated like instruments in a cosmic orchestra. Critics reacted quickly. How could fragile quantum states survive inside the brain's warm, wet environment? In laboratories, quantum coherence usually requires extreme conditions, temperatures near absolute zero, isolation from environmental noise. The idea that these delicate effects could persist at body heat seemed absurd, like expecting snowflakes to last in the desert. Skeptics called the theory speculative at best, pseudo-scientific at worst, and yet the mystery of anesthesia lingered. For decades, no one had fully explained why certain chemicals could reliably shut off consciousness while leaving much of the brain's electrical activity intact. Hameroff pointed to microtubules, suggesting that anesthetics might disrupt quantum processes within them, severing the very circuitry of awareness. It was an audacious claim, but it gave the theory a testable edge. The debate raged on. Neuroscientists argued that classical networks were sufficient, pointing to progress in artificial intelligence as evidence that computation alone could mimic awareness. Meanwhile, Penrose and Hameroff insisted that mimicry wasn't enough, that the richness of inner life required something beyond algorithms, something tied to the fundamental nature of reality. Now, imagine those microtubules inside your own neurons, billions of them forming an invisible lattice beneath your thoughts. What if, as you read these words, their oscillations are humming at quantum frequencies, stitching the raw fabric of possibility into the tapestry of experience? It is a radical image, your mind as a quantum computer, not built by engineers, but sculpted by evolution over billions of years. From here, the question becomes unavoidable. If microtubules can indeed harbor quantum states, are they unique, or are they part of a larger pattern in life itself? Nature often hides its most profound designs in plain sight. And in the next step of our journey, we'll see how plants, birds, and even your own senses may already be using quantum tricks to survive, hints that your brain is not an exception, but part of a grander evolutionary story. Step back from the human brain for a moment and look at the natural world. You might expect quantum mechanics, the strange rules of the subatomic realm, to be confined to laboratories with ultra-cold chambers and shielded detectors. Yet nature, clever as always, seems to have discovered ways to use those very rules for survival. Consider a leaf catching sunlight. Photosynthesis appears, simple light enters. Energy is converted, life continues. But when scientists probed deeper, they found something astonishing. Instead of photons following a single path, the energy moves as if it explores every possible route simultaneously. Through a phenomenon called quantum superposition, the leaf doesn't test one option at a time. It holds all options open, then collapses into the most efficient outcome. This is why plants achieve near-perfect energy transfer, something classical physics alone struggles to explain. Now imagine a robin navigating thousands of miles during migration. How can such a small creature sense Earth's magnetic field with such precision? The secret appears to lie in proteins in its eyes, where pairs of electrons become quantum entangled. That entanglement allows the bird to see magnetic fields, an internal compass made possible by the most delicate correlations in physics. The robin, in other words, carries a quantum instrument built directly into its biology. Even your own sense of smell may whisper of quantum tricks. Classical theories once claimed that odor molecules fit into receptors like keys into locks. But experiments suggest that smell depends not just on shape, but on vibration. Molecules may tunnel, slipping through barriers that should be impassable, allowing receptors to detect their quantum fingerprints. Every breath you take might involve a kind of subatomic resonance. These examples tell a larger story. Quantum phenomena are not fragile rarities locked away in physics labs. They are woven into life itself. Leaves, birds, and noses all seem to exploit the improbable, turning what once seemed impossible into everyday reality. If evolution has repeatedly found ways to harness quantum effects, why should the brain be any different? And here's where the thought becomes quietly electrifying. If plants can optimize energy with superposition, if birds can migrate with entanglement, if noses can tunnel through vibration, then perhaps the microtubules in your neurons are part of the same continuum. Not an exception, but a culmination, the place where quantum biology blooms into conscious awareness. This realization shifts the tone of the debate. What Penrose and Hameroff proposed may sound less like science fiction and more like nature continuing a theme, experimenting with quantum mechanics at every scale, from chlorophyll to cognition. Skepticism is healthy, of course, but as evidence accumulates, the question becomes not could biology use quantum mechanics, but how far has biology already gone with it? As you hold that thought, picture a thread connecting the green of leaves, the flight of birds, the scent of rain, and the sparks of your own awareness. It's a thread woven from coherence, entanglement, and tunneling nature's quantum palette. Follow it inward, and you arrive back at your own mind, where microtubules may be performing feats just as wondrous. From here, our path turns to the laboratory evidence that is beginning to close the gap between speculation and data. What happens when researchers shine light into microtubules, or when anesthesia disrupts their function? The answers are surprising, and they may be the first steps toward proving that your consciousness really does ride on quantum waves. Science advances not just on bold theories, but on the quiet weight of evidence. And in recent years, experiments have begun to reveal signals that something unusual is happening inside the brain, as signals that hint at quantum processes hiding in plain sight. Start with a curious finding from researchers in Canada. At the University of Alberta, light was directed into microtubules, and what came back wasn't the rapid collapse expected by classical physics. Instead, coherence and ordered quantum state lasted nanoseconds. It may sound fleeting, but in quantum terms, that stretch is an eternity, a window and enough for meaningful computation to occur, not just random fluctuations. Move south to the University of Central Florida. There, scientists reported that microtubules could preserve quantum states for nearly a full second. Imagine holding multiple overlapping realities for that long in the noisy environment of a living cell. It is like a violin string vibrating clearly in the middle of a storm. These findings challenge the old dogma that the brain was too warm, too chaotic for quantum effects to survive. Then came the most dramatic clue: anesthesia. For over a century, doctors have used anesthetic drugs to switch consciousness off like a light, but how they worked remained a puzzle. Neurons continued firing, electrical patterns often persisted. Why, then, did awareness vanish? A team at Wellesley College uncovered a telling detail. Anesthetics don't merely dampen neural activity, they bind directly to microtubules, disrupting their quantum behavior. In rats, when drugs that stabilized microtubules were administered, the animals resisted unconsciousness. Even under anesthesia, it was as though the drugs could protect the very circuitry of awareness, delaying the plunge into darkness. If consciousness were purely classical, this result should not exist, but it does. Now shift to Trinity College, Dublin, where researchers used advanced brain imaging to look for traces of quantum entanglement between brain regions. What they found sparked debate patterns that seem to mirror quantum correlations. Skeptics caution these could be artifacts, but supporters note even the possibility of entanglement in living human brains would be revolutionary. It suggests that awareness may be bound together not by wires of electricity alone, but by quantum threads stretching across neural networks. Taken together, these experiments form a mosaic. Each piece by itself is intriguing, but side by side, they hint at a deeper order consciousness, tied not just to firing neurons, but to quantum coherence sustained inside the brain's architecture, and yet humility is needed. None of this is final proof. Measurements remain difficult, interpretations contested, replications ongoing. Science thrives on such friction, and doubt is its necessary companion. Still, the ground beneath the old assumptions has shifted. The brain no longer looks like a place where quantum processes are impossible. Instead, it looks like a frontier where those processes might shape the very essence of awareness. As you reflect on that, notice the quiet strangeness of your own perception. You are not experiencing disjointed fragments of sound, color, and thought. Somehow, all of it binds together into a seamless whole. The next step in our journey is to ask how that unity arises, why your mind feels like a single field of awareness rather than billions of scattered signals. And it is here that quantum coherence offers one of its most intriguing possibilities. Pause for a moment and notice the richness of what you are experiencing right now. The words you're hearing, the rhythm of your breath, perhaps the faint hum of your surroundings somehow. All these threads weave seamlessly into a single tapestry of awareness. This unity is so natural you rarely question it. Yet for science, it remains a riddle. How does the brain bind countless signals into the singular experience of you? Neuroscientists call this the binding problem. Each sense is processed in different regions: vision here, sound there, touch elsewhere. Billions of neurons fire in parallel, each carrying a fragment of data. By classical reasoning, your conscious mind should resemble a shattered mirror, shards of information with no coherent whole. And yet, what you experience is not fragments, it is a unified field. Here is where quantum theory steps into the conversation. If microtubules inside neurons maintain coherent quantum states, then separate brain regions could be linked not by slow electrical signals, but by instantaneous quantum correlations. Instead of mailing letters across a city, information would be shared as if the entire city were humming the same invisible tune. Your awareness would not need to assemble pieces, it would arise as a symphony, already integrated. Picture it like an orchestra. Each neuron is a musician playing its part. Classical neuroscience imagines a conductor laboring to keep everyone in sync, an impossible task at such scale. But if the players are quantumly entangled, then when one strikes a note, the others resonate instantly. The music is not coordinated by effort. It is bound together by the physics of coherence itself. This view offers a graceful solution to why your experience feels whole. Quantum coherence could act like a hologram, where every part carries information about the whole. When you see a color, hear a note, and feel an emotion, they are not merely juxtaposed, they interpenetrate, forming a single field of lived experience. Skeptics rightly caution that this is still theoretical. Entanglement in brains is difficult to measure. Alternative explanations exist, but even as a possibility, it reframes the mystery. Your mind may not be assembling fragments into a unity, but revealing an underlying unity already present at the quantum level. Now, take a breath and reflect on what that means for identity. The sense of being oneself, not a pile of disconnected processes, may be the experiential echo of quantum coherence binding your neural orchestra together. It is not proof, but it is a story that resonates with what you feel from the inside, that consciousness is not many, it is one. From here, the path widens. If coherence can unify the scattered networks of your own brain, could similar principles link minds beyond the skull? Might awareness extend outward, entangled with the quantum field itself? That is where our journey now turns toward the possibility of connection across space, across time, perhaps even across individuals. Take another breath and imagine the edges of your awareness. For most of your life, you've been told those edges lie at the boundary of your body, your mind inside, the world outside. But what if those boundaries are less like stone walls and more like mist, porous to something deeper? Quantum entanglement suggests such permeability. Two particles, once linked, remain connected no matter how far apart they drift. Change one and the other responds instantly, even across light years. Einstein called it spooky action at a distance. Yet it is now one of the most tested, reliable facts of physics. Now extend that principle to consciousness. If microtubules in your neurons sustain entangled states, then your awareness might not be confined to the wet architecture of your brain. Instead, it could share information with the wider quantum field, perhaps even with the minds of others. What you call empathy, the sudden resonance with another person's joy or pain, might be more than metaphor. It could be the faint echo of quantum entanglement whispering across invisible channels. Some experiments hint at this possibility. At Trinity College Dublin, researchers recorded patterns that looked suspiciously like quantum correlations between distant brain regions. The data is debated, interpretations contested, but the suggestion alone reshapes the question, what if your mind participates in networks larger than itself? Consider moments from your own life. You walk into a room and instantly feel the atmosphere before anyone speaks. You think of a friend seconds before they call. Ordinary explanations exist, but perhaps they are not the whole story. Perhaps consciousness can stretch across boundaries, entangling for brief flashes with the fields of other minds. Humility matters here. This is not a license to claim telepathy or cosmic oneness as proven fact. The evidence is fragile, incomplete, often controversial, but as a thought experiment, it invites you to see your own mind differently, not a sealed vault, but a participant in a shared fabric. Picture the quantum field as a vast ocean. Each individual mind is a wave distinct in form, yet inseparable from the water that sustains it. When one wave rises, nearby ripples respond. Awareness may work in the same way, local and unique, yet always part of something larger. From here, the implications grow bold. If minds are entangled, then consciousness might not be an isolated spark, but a field phenomenon, woven into the cosmos itself. That brings us to the heart of an even stranger possibility, that perception is not merely passive reception, but an act of creation consciousness collapsing waves of possibility into the definite world you know. Close your eyes for a moment, if you like, and picture the world vanishing into a blur of possibility. No solid objects, no fixed colors, just an ocean of overlapping potentials. This is how quantum physics describes reality, before measurement particles existing in superposition, occupying all possible states at once. Now consider your awareness. Every sight, every sound, every thought emerges not as an accident, but as the collapse of those possibilities into one definite experience. You are not merely looking at the world, you may be helping make the world, one moment at a time. This puzzle is known as the measurement problem. Why does a particle's wave of possibilities collapse into a single outcome only when observed? Physicists debate fiercely. Some say it happens through interaction with the environment. Others argue for spontaneous collapse, and a daring minority suggests something more radical, that consciousness itself plays a central role. Imagine your awareness as a cosmic selector, choosing which version of reality crystallizes from the sea of probabilities. When you see a red rose, your brain doesn't just register an input. It may be collapsing countless quantum options into the definite experience of red. In this sense, perception is creation. Every conscious moment is a tiny act of world-making. The American physicist John Wheeler once proposed a participatory universe. Reality, he argued, is not a fixed stage upon which you act, but a performance that only exists when you participate. Information, the yes, no of quantum events, becomes it, the building block of existence. Your observation actualizes the script. Skeptics remind us that this interpretation is not universally accepted. Many physicists prefer less mind-centered explanations. Yet the experiments remain unsettling in the famous double-slit experiment. Particles behave like waves until observed, then snap into particle form. The presence of an observer changes the outcome, as though consciousness leans over the quantum canvas and brushes in the final strokes. Think of memory as an example. Each time you recall the past, you are not retrieving a perfect photograph. Instead, you are collapsing a range of possibilities into one chosen version. That's why memories change. They are recreations, not recordings. Your mind may be shaping not just the present, but the very texture of your past. This view transforms ordinary awareness into something extraordinary. The simple act of noticing the sound of your breath, the warmth of your skin, the meaning of these words may be reality itself coming into focus through you. You are not outside the universe, looking in. You are inside the process, a participant in creation's unfolding. From here, the journey deepens. If your choices, your memories, your perceptions all emerge from quantum selection, then what does that mean for free will, for identity, for the sense of being a self? That is the next mystery to unravel, the role of consciousness in shaping not just reality, but the story of who you are. Take a breath and think about the last memory you called to mind. Maybe it was breakfast this morning, or a childhood moment that still glows in your imagination. Now ask yourself, how accurate is that memory? Was it preserved like a photograph, or reshaped slightly each time you remembered it? Neuroscience shows that memory is fluid. Each act of recall modifies the past, restoring it in altered form. But from a quantum perspective, this takes on a deeper resonance. What if your memories exist in superposition, multiple versions lingering in potential, until the act of remembering collapses one into your conscious experience? You are not retrieving the past so much as creating it anew each time. This fluidity points to a larger mystery, the nature of identity. You experience yourself as a stable self, a continuous I stretching from birth to now. But beneath the surface, your brain and body are in constant flux, cells dying, neurons rewiring, microtubules oscillating. So what anchors your identity? Perhaps it is not the hardware of flesh, but the coherence of quantum processes that bind moments of awareness into a narrative thread. The you of today may not be the same as yesterday in a physical sense, but quantum coherence might weave continuity from change. Then comes the hardest question of all free will. Classical physics paints a deterministic picture. Every choice, in theory, could be traced back through a chain of causes. Neurons fire because molecules move. Molecules move because atoms collide. Atoms collide because of prior conditions. In such a universe, your decision to turn left instead of right was inevitable from the beginning of time. Quantum mechanics complicates that story. Superpositions collapse unpredictably. outcomes are not predetermined, only probable. If consciousness is involved in that collapse, then perhaps your choices are not scripted in advance. They emerge from a realm of possibilities, shaped but not fixed, guided but not chained. Your will would not be random, nor would it be mechanical. It would be quantum, a blend of freedom and indeterminacy. Consider the decision you are making right now to continue listening, to reflect, to imagine. Where did that choice originate? Not solely in the predictable machinery of neurons, and not in blind chance alone. It may have emerged from a quantum dance inside your microtubules, where possibilities collapsed into the singular path of yes. This possibility reframes responsibility. You are not a puppet on the strings of physics, nor a ghost outside the system. You are a participant whose awareness helps shape which version of events unfolds. Your life becomes a collaboration between the laws of nature and the openness of possibility. Of course, questions remain. Does quantum indeterminacy truly grant freedom, or is it just another layer of unpredictability? Does identity arise from coherence or from narrative memory? These debates are unresolved. But reflecting on them can change how you see yourself, not as a passive spectator, but as an active co-creator of your own story. And that story does not end with the self. If individual consciousness can shape reality at the quantum level, what happens when billions of minds participate together? What might collective awareness do to the fabric of the world? That is where our path leads next, toward the possibility of a global consciousness. A human symphony resonating through the quantum field. Picture billions of lanterns scattered across the night, each one glowing with its own flame of awareness. From far away, they seem separate. But as the light spreads, the glow begins to overlap, forming one vast radiance across the horizon. This is the metaphor for collective consciousness, the possibility that individual minds, though distinct, may join through quantum processes into something larger than themselves. Hints of this idea appear in both science and experience. At Princeton University, the Global Consciousness Project has tracked random number generators placed worldwide. During major global events, moments when human attention converges, the supposedly random patterns shift toward order. Skeptics dispute the interpretation, but the pattern has persisted for decades, as if shared focus can ripple into physical systems. Meditation research adds another layer. Advanced practitioners often describe dissolving the boundary between self and world, merging into an oceanic sense of unity. Brain scans reveal striking quantum-like coherence during such states. Neural oscillations align across regions. Microtubule activity may synchronize, and the subjective experience of oneness correlates with measurable order in the brain. It is as though tuning inward tunes you outward as well, linking personal awareness to something vaster. Psychedelic research tells a similar story. Substances like psilocybin and LSD consistently generate experiences of cosmic connection. People describe feeling part of a universal mind, woven into the fabric of existence. And neuroscientists have found that during these altered states, patterns of coherence in the brain dramatically increase, echoing the possibility that expanded awareness has a quantum signature. But the most intriguing clue may come from simple human connection. Have you ever felt someone's mood before they spoke, or shared a laugh that seemed to ripple instantly between you without words? Perhaps these moments are micro-glimpses of entanglement, subtle hints that minds can resonate together across invisible threads. If consciousness can reach beyond the skull, then collective intention could matter in ways we barely comprehend. Imagine millions of people holding compassion, clarity, or creativity at once, not just in philosophy or poetry, but in physics, Coherence fields overlapping, strengthening, influencing probabilities at the quantum level. This is speculative, yes, but it reframes human potential not just as isolated achievement, but as shared resonance. The idea is humbling. Your awareness is not just private property. It may be part of a network, a chord in a symphony. What you hold in mind, your clarity, your compassion, your attention may ripple outward more than you realize. And yet, caution remains. These studies are controversial. The mechanisms unknown, we must tread carefully between wonder and wishful thinking. But even with that humility, the suggestion is profound that human consciousness may scale, and that together we might shape reality in ways impossible alone. From here, we arrive at the necessary pause, the reminder that not all scientists agree, that many argue classical processes suffice, and that the mystery of consciousness remains unsolved. As our journey nears its close, we will face these challenges directly, acknowledging the skepticism while honoring the beauty of the unknown. Every bold idea must eventually pass through the fire of scrutiny. Quantum consciousness is no exception. For all its wonder, the theory faces deep challenges, and many scientists remain unconvinced. One major objection is sufficiency. Neuroscience has mapped countless correlations between brain activity and conscious states using classical models. Billions of neurons, wired in complex networks, can explain perception, memory, even decision-making without invoking quantum mechanics. Artificial intelligence adds weight to this view. Vast classical systems can mimic human cognition, raising the question of whether awareness really requires quantum computation at all. Another challenge is fragility. Quantum effects are notoriously delicate, collapsing under heat and noise, while experiments in photosynthesis and microtubules show surprising resilience. Critics argue these effects may not scale to explain full consciousness. A few seconds of coherence in a protein, they say, does not equal the rich tapestry of subjective experience. Then comes the hardest mystery, the explanatory gap. Even if quantum processes exist in the brain, why should they feel like something from the inside? Why should a quantum collapse be experienced as the color red, or the taste of salt, or the ache of nostalgia? This is what philosopher David Chalmers called the hard problem, and quantum theory has yet to solve it. Some researchers suggest that perhaps consciousness is fundamental, not emergent, just as mass and charge are intrinsic to particles. Perhaps awareness is intrinsic to quantum information itself. This perspective, sometimes called panpsychism, stretches beyond mainstream science, yet it reflects the humility required when we face mysteries this deep. Skeptics play a vital role here. They demand rigor, replication, and restraint. Without them, enthusiasm risks drifting into fantasy. And yet, even critics often admit consciousness remains unsolved. The classical story explains function, but not the feeling of being alive. In that gap lies room for exploration, for imagination, for new frameworks still to be born. What emerges then is a kind of balance. On one side, evidence accumulates microtubule coherence, anesthetic disruption, entanglement hints. On the other side, doubts persist, classical sufficiency, fragility, the explanatory gap. Between them stretches the frontier of science, where certainty dissolves and wonder endures. And maybe that is the gift of quantum consciousness, proven or not. It reminds us that the mind is not trivial, not easily reduced, not fully mapped. It keeps the mystery alive in an age hungry for answers. It suggests that your awareness, ordinary, every day, right now, may be more extraordinary than you ever suspected. As we move toward the close of this journey, it is time to soften the pace. to let the data and theories fade into a quieter resonance, to rest, not in conclusions, but in the beauty of not knowing, and to invite you, gently, into reflection what it means to be a conscious participant in a universe still unfolding its secrets. Settle back for a moment. Let the details of theories and experiments drift like distant echoes. What remains is the simple fact that you are aware right now, listening, reflecting, breathing. That in itself is extraordinary. We have traveled across landscapes of speculation and evidence, from the hidden circuits of microtubules to the vast ocean of entanglement, from the fragility of quantum states to the mystery of collective mind. And through it all, one truth has stayed constant: consciousness. Your consciousness remains one of the deepest wonders we can contemplate. Maybe the quantum theories will hold. Maybe future experiments will prove them wrong. Either way, the mystery is not diminished, it is deepened. Because what matters is not certainty, but the living presence of awareness itself, the fact that the universe has found a way, through you, to notice itself. So as you rest tonight, let yourself drift into that thought. Your mind is not small. It may be a lantern in the dark, but its light touches the infinite. Whether through quantum entanglement, classical complexity, or something we cannot yet name, you are part of the unfolding story of existence. Take comfort in that. Let the questions remain open, like stars still waiting to be charted. You don't need every answer to feel wonder. You don't need proof to feel awe. It is enough to breathe in the mystery and know you are woven into it. And when you wake tomorrow, the world may look the same: streets and skies, voices and routines, but perhaps you will carry a quieter knowing that every perception, every choice, every memory is not just a passing flicker, but a moment of creation, a note in a cosmic song. Rest well. Then, let your awareness dissolve into the rhythm of sleep, knowing that in some profound way, the universe is dreaming through you, and you are part of that dream.